Hello, my name is John Hoadley, Director of Product Marketing at Casa Systems. Today we'll be going through a demonstration of Casa's Axyom Cloud Native 5G Core. During the demonstration, we'd like to focus on three key areas. The first will be network slicing. And network slicing is the cornerstone feature of the 5G Core, and it uses the new service-based architecture. Now, network slicing is the ability to create a logical network that has different parameters for each different user, in fact, each different session. And those parameters would be different latency, different throughput, different availability, different reliability, different security capabilities. And the best way to think of network slicing is really to think of a few examples. So a couple examples, let's focus first on IoT, the Internet of Things. Now, with the millions of sensors out there, many are doing different tasks. Some are doing mission-critical tasks like autonomous driving or monitoring a gas pipeline. Latency is incredibly important. Availability and reliability must be delivered, but the throughput isn't all that great, and the number of sessions may not be all that large. So that's a slice. Another slice could be, again, with the Internet of Things, just monitoring. Monitoring meters, monitoring rainfall. In those cases, latency isn't as important. It doesn't matter if the packet arrives within a millisecond, a second, a minute even. But the number of transactions can be huge. It can be millions and tens of millions. Again, that's another slice. A third example would be augmented or virtual reality. In that particular slice, you need very low latencies, but also huge throughputs. And we could keep on going on with different types of slices, but I think you probably get the idea. Network slicing provides a great revenue opportunity for the service providers with all of these new applications. And each of these slices can be charged separately. Next, we'll focus on microservices. Casa's 5G Core is an NFV solution made up of virtual network functions, or VNFs. For example, the access management function, or the session management function. But each of these VNFs is comprised of microservices. And those microservices are designed from the ground up for maximum throughput and maximum flexibility. Now, those microservices can be reused within different VNFs within a single application, such as the 5G Core, but they can also be reused in other applications, such as Casa's virtual BNG, used for fixed broadband, or virtual CCAP for cable broadband. The final area we'll focus on is containers. Casa's 5G Core uses Docker containers that are orchestrated by Kubernetes. And what this provides is a seamlessly scalable network that is both reactive and responsive. So now let's move on to the demo itself and look at the setup. The diagram shows key VNFs in the 5G Core architecture. As you can see, there's a separation of the control and user plane. This was first introduced with 4G cups, and you can see that in another Casa video demo. The separation of control and user plane allows for flexible geographic location of the VNFs. For example, a user plane VNF could be located at the edge of the network for low latency applications. In the demo, the control plane VNFs are in a Kubernetes cluster. Let's zoom in on an example 5G Core VNF. We've chosen the session management function. All of the VNFs are composed of microservices, which are orchestrated by Kubernetes. Each of the microservices are realized as Kubernetes pods using the Kubernetes terminology, and the number of pods can be scaled up and down as needed. Finally, the OANM of the VNFs is done with Yang and OpenAPI modeling. What we're looking at here is the Kubernetes Cube App display, and it shows several of the VNFs used within the 5G Core. Each of these VNFs is managed by a Helm chart, and you can see some of the VNFs, for example the AMF, and two SMFs, which will be needed to implement the two slices. Now we're looking at the Kubernetes dashboard, showing multiple pods which represent multiple microservices. Let's look at the pods, which show the actual instances of the microservices that are running. For example, with the SMF, there's the IP address manager and the session manager. Note that there's several microservices: the database, Redis, the messaging service, RabbitMQ, and the management service, that are microservices which are shared across multiple VNFs. Now that we have our 5G Core network established and provisioned, let's move on to the actual slicing demonstration. On the screen, you can see that we will establish two separate data sessions from a single UE. And each of these data sessions will have different network characteristics. The UE first registers on the network through the AMF. The next step is slice selection, where SMF UPF pairs are identified. And finally, PDU sessions are set up and data is flowing. At this point, we have fully established slices. The CLI display shows that we're generating simulated traffic from a single base station. On the display, we can now see that we've established a single user, which has an identifier SUPI, which is the 5G equivalent of an IMSI, and this single user has established 2 sessions. You can see that we have 2 slices up and running. We've got a single AMF, but now 2 SMF UPF pairs, and each of those pairs represent different slices. Also, the output shows there's 2 PDU sessions, each with different NSS AIs. You can see the session associated with the first UPF, or first slice. And now we're going to be showing data flowing through that slice. And that traffic continues to build. Now we've moved on to the second slice, the second UPF, and you can see the session here. And again, data is flowing through this slice. And it continues to build. You've just seen our Axyom 5G Cloud Native Core in action delivering network slices. Our Kubernetes container-based implementation delivers seamless scaling, and our microservices design delivers software flexibility. If you're interested in getting more detailed demonstration or finding out more information, please contact a Casa sales representative or reach out to us at casa-systems.com.